Question 9. We have an equation that involves algebraic fractions, and there are two ways for you to solve this. There's actually more than two ways, but two of the simplest ways are what I'm going to show you just now. So the first, which is quite intuitive when you see a pair of algebraic fractions, is to do the sum that's involved. So this here, this takeaway sum, we're going to go ahead and do that. In order to do that, we need to first of all have our denominators the same before we can do the takeaway sum. So in order to get our common denominators, we need to look at the blue bracket and the green bracket and ask if they have anything in common. They don't. So in this case, our common denominator is just both of them multiplied by each other, like so. I then need to change the sixes at the top of each fraction so that they are the same size as the fraction before. So in order for this fraction to turn into this one, we need to times top and bottom by x plus 1. And then for the other one, we need to times top and bottom of that fraction by x minus 2, giving us the following. I recommend writing this as a single fraction before you break out any brackets. So I'm going to rewrite this first and then we'll just keep it the same color now. Write it like that. Main reason is because quite often I see people expand this bracket but then forget that this negative applies to all of it. If you write it as a single fraction first, you're far less likely to make that mistake with a negative. So breaking out the brackets in the top now, we're going to end up with 6x plus 6 minus 6x plus 12. Sorry, we still got an equals 1 on the right. The denominator, I don't have to break out at this point. It doesn't really matter whether or not you break it out now or later, but generally speaking in an algebraic fractions question, you wouldn't break it out. So I'm just going to leave it like that for now. The numerator then simplifies to being just 18 because the x terms cancel each other, and then I'm going to be left with this. Now, as far as the algebraic fractions part's concerned, what I started with in the red box and what I've ended with there, you have successfully subtracted those two fractions together. But we have an equation to solve, which means we don't just stop there, we've got to actually figure out what x is. Now, whenever you've got an algebraic fractions type like this, where you do some stuff on the left-hand side and then you have an equation, we're looking to basically get rid of that fraction by multiplying both sides by that denominator, which is going to make us have in x minus 2 and x plus 1 multiply and appear on the other side. Now, the fact that there's a 1 here means that I don't even need to consider it, but just be careful if this was a number like 2 or 3 or 4, you'd have to take care when you're breaking this out. So I break out the brackets on the right hand side, paying no attention to that 1 because it doesn't do anything. We're going to end up with an x squared plus x, then we're going to have a minus 2x minus 2, and already you can see we now have a quadratic equation, which means we need an equals 0. So that 18 is coming over here on the next line. Plus x minus 2x will give us a minus x. We still have that takeaway 2. That then becomes x squared minus x minus 20. And you can use the formula technically, but this factorizes quite nicely. Factors of minus 20 that add to make minus 1. We have all of the following here, and a 4 and minus 5 are going to be the ones that we want. So we have a plus 4 and a minus 5 in our brackets. No, plus 4 minus 5 in our brackets equals 0. We then set each one equal to 0 and solve. So x plus 4 is 0, giving us x is minus 4. That's the first answer. Or x minus 5 is 0, giving us x is 5. That's the second answer. So x is minus 4 or x is 5. That's the first way of doing it. Second way of doing it is not looking at the fact that we have an algebraic fraction, but looking at the fact that we have an equation. When you have an equation, you can do whatever sums you want to both sides. So I can actually save myself all of this algebraic fraction stuff if I just spot that the first step I can do here is multiply both sides by the fractions in order to make them disappear. So I'm going to multiply both sides of the equation by the double brackets. On the right hand side, we're going to have a 1 times this stuff, which is going to give me exactly the same thing as I had here. I don't need to write the 1 in, so I'm not going to. I'm just going to put x minus 2, x plus 1. On the right hand side, there's multiple ways of doing this. One of the ways that you can do it is just to imagine that the two double brackets are sitting there right beside the 6. And hopefully you can spot that the whole point in doing this was to make the denominators cancel. So the x minus 2 that was on the top, that's going to cancel with the x minus 2 on the bottom, and then vice versa. The x plus 1 that was here is supposed to cancel, and you're going to be left with the x minus 2 that was the other bracket. If you can see that, then technically you can just write out the following straight away. 6 with this bracket, x plus 1, and then we have a minus 6 with this bracket, x minus 2. So multiplying both sides by the double brackets, x minus 2 and x plus 1, allows us to get at that stage, and this just cuts out a lot of the work, because now I've got brackets to break out and stuff like that, but I don't have any of the fraction stuff here, and I will end up doing less workings as a result. This stuff here ends up becoming 18, this stuff here ends up becoming x squared minus x minus 2, and we basically follow the same process from here. Quadratic equation, from here. Quadratic equation, we need it equal to 0. Solve, blah, blah, blah. Done.